This section examines gear selection. A gear shift lever allows the driver to manually select gears via a gear shift mechanism. The lever can be mounted remote from the gearbox, on the floor or on the steering column, and connected to the gearbox by a rod linkage or cables. It can also be mounted in the top of the gearbox, where it acts through a ball pivot in the top of the extension housing. In this design, the lower end of the gear lever fits into a socket in a control shaft inside the transmission extension housing. A short lever on the other end of the shaft is located in a selector gate formed by slots in the 3 selector shift rails. They are supported in the casing and are moved backwards or forwards by the lever. One rail moves to engage first or second gear. Another serves to engage third or fourth, and the other operates fifth or reverse. A selector fork is attached to the first and second shift rail. It sits in a square section groove on the outside of the first and second engagement sleeve. Similarly, for the selection of third and fourth gears, the reverse selector fork engages in a groove in the reverse engagement sleeve. Lateral movement of the gear lever positions the control rod in line with the appropriate selector rail. Longitudinal movement is transferred through the control rod and selector rail to the fork and the engagement sleeve. Each rail has a detent mechanism, usually in the form of a spring-loaded steel ball held in the casing. The ball engages in a groove in the rail when the gear lever is in neutral, and in a similar groove when a gear is selected. This holds the gear in detention in the selected position. When a gear is changed or selected, an interlock mechanism prevents more than one gear being engaged at the same time. In this design, 2 steel balls locate in the casing between the center and the outside shift rails, and in alignment with grooves machined in the shift rails. A small plunger is captive in a hole drilled in the center rail. In the neutral position, the balls and plunger can move laterally. But when an outside rail is moved, the ball is pushed sideways to contact the plunger and move the opposite ball into the groove of the other outside rail. The 2 balls held in the casing prevent movement of the interlocked rails and hold them in the neutral position. When the center rail is moved, the balls move into the grooves of the outside rails and hold them in a similar manner. All gearboxes are fitted with interlock and detent mechanisms, although designs vary according to manufacture.